Hello, here we are in 7.2, systems of linear equations in three variables, okay? This is basically a continuation of 7.1 when we had systems of two variables with two equations. And this is just kind of adding another layer of difficulty on this. But it's basically the same thing. So if you can handle 7.1, I don't think you'll have too much trouble with 7.2. It just takes a little longer to solve them, but the technique is pretty much the same way. So let's begin with the objectives. The first objective is we're going to verify the solution of a system of linear equations in three variables. We're going to solve a system of linear equations in three variables, and we're going to solve problems using systems of three variables. Okay? So let's first begin with what is a system of linear equations in three variables and their solutions. So in general, any equation of the form ax plus by plus cz equals d, where a, b, c, and d are real numbers such that a, b, c are not all zero. Now that doesn't mean one of them can't be zero. They just can't all be zero at the same time. Okay, so A could be zero, but B and C may not be. Okay, or actually you could have one of them just known and the other two are zeros. Okay, but that would be kind of a trivial case if that was the case. But what this is basically saying is all three of them cannot be zero at the same time. Alrighty, is a linear equations in three variables x, y, and z. So the solution of a system of linear equations in three variables is an ordered triple. Now notice it was an ordered pair in the last section because there was only two variables, x and y. Now you have a third variable, z. So we'll have it as an ordered triple, and you'd write it kind of like an ordered pair. You'd have like a parentheses, x, comma, y, comma, z this time, and close the parentheses. And we call that an ordered triple, not an ordered pair, because there's three of them. And the ordered triple of real numbers that satisfy the equations of the system. The solution set of the system is a set of all of its solutions. So you could have more than one if it's the same plane, basically. But if it's just a single point, then it's just an ordered triple. It's a single point. Alrighty? So let's begin with an example, and we're going to start with an easy one. Here, this is an example. We're going to just determine whether an ordered triple satisfies a system or not. So we're going to show that the ordered triple, -1 is the x, -4 the y, the 5 the z. We're going to prove that that is a solution to the system. X minus 2y plus 3z equals 22, 2x minus 3y minus z equals 5, and 3x plus y minus 5z equals -32. So we're going to prove that that ordered triple, -1, -4, and 5 is a solution. So all we're doing is taking each one at a time and plugging in or substituting those numbers in for each x, y, and z of that particular equation. So when you put the -1 in for the first equation, you get -1 minus 2 times -4 plus 3 times 5. And we want to know if that equals 22. So we work it out. -1, okay, then plus 8. And then plus 15. -1 plus 8, of course, is 7, and 7 plus 15 is 22. So that one checks out. Now, just because it works for one doesn't mean it's going to work for all of them, okay? So it's got to satisfy all three in this case. So we take the second equation, 2x minus 3y minus z equals 5, and we put the order triple in that one. So 2 times -1 minus 3 times -4 minus the 5, because remember it's a minus z, and we want to know if that equals 5. So we do -2 plus 12 minus 5, and -2 plus 12 is 10. 10 minus 5 is 5, and 5 does equal 5. So that one checks out. So two of them are satisfied. It's got to work for the third one as well, though. So we take the third equation, 3x plus y minus 5z equals -32, and we put the order triple in that one. And so we have 3 times -1, okay, plus y, which is -4, and then minus 5z. Remember, z is 5, and so we work that out. It becomes -3, okay, minus 4, and then plus 25, okay, or minus 25, I should say. And you work that out, and it'd be a -3, -4 is -7, and -7 minus 25 is a -32. That one checks out. The order triple, -1, -4, 5 satisfies all three equations. it makes each equation true. Thus, the ordered triple is a solution to the system. So you might ask, well, what if it works for 2 but not the third one? Then it's not a solution to the system. It has to work for all 3. Okay? So it's all 3 or nothing. Okay? If it doesn't work for one of them, it won't work for the system. It may work for the other 2, but it doesn't work for the system. Remember, the system is basically a package. It's a package deal. And so if it works for all 3, then it's a solution. But if one of them is discarded, then it's not a solution to the system, even though it might work for the other 2. Okay, let's look at this one. Solving equations of linear equations in 3 variables by eliminating variables. Okay, we're going to give you a little recipe here of how to solve these things. Now, the last equation, I would just given the answer, the ordered triple, and I had to check to make sure they were solutions to all 3. This one is we're going to have to come up with the solutions ourselves. Okay, so this is the technique of how do you do it. And it's going to look very familiar from what you did in 7.1, by the way. Okay, number 1, reduce the equations to 2 equations and 2 variables. This is usually accomplished by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. So you take the addition method and you subtract the same variable from both equations. Then that creates a system of 2 equations. So you solve the resulting systems of 2 equations like you did back in 7.1, and you can do that either by the addition method or the substitution method. That kind of is your choice, okay? And the result of that equation is in one variable that gives the value of that variable. So you solve that system for one of the variables. Then you back substitute the value of that variable back into step 2 to find the other equation from that step, or the other variable from that step. So now you'll have 2 variables, you know. Okay, and so you find the second variable. Okay, now that you got 2 of them, we're going to use the values of the 2 variables from steps 2 and 3 to find the value of the third variable by back substituting into one of the original equations. And then you check the proposed solution in each of the original systems, and original equations, and if they work, if they check out and then it works, then you know that is a solution. Okay, then that is a solution to the system. So 5 again is like the check technique, and checking is not really a requirement. It is probably recommended, especially if you have time at the end of the exam and you're trying to find something to do. That would be a good thing to do, is to check it. Okay, and I'm hoping you guys are writing this one down. These 5 steps is a very important when you're trying to do these things yourself. Even though it's easy, it becomes really tedious, and you sometimes can get lost in your own work because there's so many numbers all over the place, and when you're trying to solve it, and so many equations all over the place, it's sometimes you got to get them mixed. You get them mixed up. But the bottom line here is you have 3 equations with 3 unknowns. You use the addition method to eliminate one of the variables in 2 of the equations. Now you have a system of 2 equations. You solve that the way you did back in 7.1. Now you have the answers to 2 of the variables. And then you use those 2 variables solutions and put that back into one of the original equations to find the third. So it's a little recipe, but that's the technique that would be best suited here. Okay, so let's look at an example. Okay, this one's got 2 steps. We're going to solve a system of equations with 3 variables. So we have an equation, x plus 4y minus z equals 20. We have another one, 3x plus 2y plus z equals 8. And 2x minus 3y plus 2z equals negative 16. So we're hoping that there's an ordered triple that satisfies that. And you might ask, well, what if there isn't one? What happens there? Well, if that happens, in the process of trying to solve it, you get an equation that is never true, like 6 equals 4. Remember we did that last time? If you get a statement that is never true, then that system will have no solution. So sometimes people want those things to happen because they can quit right there and say no solution. It's inconsistent, in other words. Okay? So they want that to happen. A lot of times that doesn't happen because most of these will have a solution. Alrighty? So let's begin. Okay, so what we're going to do is, here's a solution. We're going to reduce, step one is to reduce the system to two equations and two variables. So what I'm going to do is I'm going to use the first equation and the second equation of the system to try to eliminate the z. So what I do is I take the two equations and add them together. If I add them together, I get basically 4x, okay, plus 6y equals 28. And then I take the first equation with the third equation, and I multiply that equation times 2 on the top, and it becomes 2x plus 8y minus 2z equals 40. You know, why do you do that? It's because the bottom equation has a 2z. And when you add those equations up, you get 4x plus 5y equals 24. So notice when I combine the first equation to the second equation, the z's were eliminated. And so you have an equation that involves only the x and the y, 4x plus 6y equals 28. And then on the second equation, I had to multiply the top equation times 2 first to get that in the form of negative 2z. And then add that to the bottom equation, not the second equation, but the bottom equation this time, and you get 4x plus 5y equals 24. So these two equations become my new system of two equations. So I take those and I round those up. So 4x, okay, plus 6y equals 28, and 4x plus 5y equals 24. And so all I'm going to do is I'm going to take the bottom equation and multiply it by negative 1 so I can eliminate the x's. So if I do that, I get 4x and negative 4x gone, and then 6y and negative 6y is going to be y, and then 28 and a negative 24 is 4. So y is 4. So y would be equal to 4 in all three of those original equations. So step 3, okay, we're going to back substitute that one equation back into the remaining system of two equations, and so we can find the second variable. So we plug the 4, substitute the 4 back in. So we have 4x plus 6 times y, which is 6 times 4. Now you could put it in the other equation, and that's perfectly fine. But they decided to put it into the first one. And then 6 times 4, of course, is 24. And then it turns out that x is 1. So x is 1 in all three of those original equations. Just like y equals 4 in all three of those original equations. So now what we're going to do is we're going to back substitute the variables we found for the two variables back into one of the original equations, and they chose the first one. So x plus 4y minus z equals 20. So remember we found y to be 4 and z to be what? Or x to be 1. So we got to find z now. So x was 1, y was 4. So we do the math. That's 17 minus z equals 20. And then do the calculation. Z is equal to negative 3. So the proposed solution is 1 for x, 4 for the y, and z to be negative 3. That's the proposed solution. Now again, step 5 is an optional step. You don't really have to do it because it does take a lot of time. It's just a feel-good kind of a thing. But the order triple 1, 4, negative 3, if I made no mistakes, that is the solution. So I put them back in, and the first equation, 1 in for the x, 4 in for the y, z is negative 3, and it turns out 20 equals 20. Yes, it is, and that's true. And then when I put those same three numbers, 1, 4, negative 3, into the second equation, I end up with 8 equals 8. Is that true? Yes, that's true. When I put 1, 4, negative 3 into the third equation, you end up with negative 16 equals negative 16. Is that true? Yes, it is. So therefore, all three of them are true. So that is indeed, that order triple is indeed a solution to those three. So that's the solution set, 1, 4, negative 3. And that is the only ordered triple that works for all three of those equations. Not to say that there's not ordered triples that work for 1 or 2 at the same time, but that is the only one that works for all three of them at the same time. Okay? All righty. Now let's look at an example and look at an application. Okay, this one is an application that is kind of pretty hairy sometimes. Can cause a lot of troubles with students. What we're going to do is find a quadratic function, y equals ax squared plus bx plus c, so we've seen that a few times, whose graph passes through the points 1, 4, 2, 1, and 3, 4. Notice, there is no vertex. They don't give us any of the vertex. They just give us 3 arbitrary points that the parabola goes through. And of those 3 arbitrary points, they want us to find the actual quadratic function that this thing goes through. So let's begin. So we begin by substituting each ordered pair into the equation y equals ax squared plus bx plus c. So we begin with that. So we plug the 1, 4 in for the x and the y. So 4 equals a times 1 squared plus b times 1 times c times, I'll just see because there's no x on that one. So x was 1 and y was 4, remember. So you do the math on that. 1 squared times a is a, b times 1 is b plus c. So the first equation of our system is going to be a plus b plus c equals 4. Okay, because that's by plugging the 1, 4 back into the equation. Remember, we don't know the a, b, and the c. If we can find those, if we can find the a, the b, and the c, we have the function. And that's the point. We want to know what the function is. So we need to know a, the b, and the c. And so what they're doing is they're plugging in the 1 and the 4 and the x and y, because that's the only thing you know at this point is the x and the y coordinates on 3 ordered pairs. So then you do it again. But this time you put in 2 in for the x and 1 in for the y. So 1 equals a times 2 squared plus b times 2, because x is 2 this time, and the c. So in this case, you'll have 4a plus 2b plus c, because 2 squared is 4, 4 times a is 4a, and then b times 2, of course, is 2b, and the c comes down. And then in the third equation, 3, 4, 4 is for the y, and 3 is for the x. So we get 3 squared, which is 9, and then b times 3 is 3b plus c. So there are your 3 equations. I know, like they were in the form of x, y, and z a while ago. Now they're using a, b's, and c's. It's the same thing, they're just using different letters. So the a, b, and the c's, okay, are just like the x, y, z. And this is an order triple as well. We're just trying to figure out what the a, the b, and the c are. Okay? So to find a, b, and c, we form a system with 3 equations and solve the system. So step 1, reduce the system of equations into 2 variables. So the first equation, a plus b plus c equals 4. The second one is 4a plus 2b plus c equals 1. And then the 9a plus the 3b plus the c is 4. So what we're going to do is we're going to take the first equation, a plus b plus c equals 4, and the 4a plus 2b plus c equals 1, okay? And then we're going to multiply the bottom equation times negative 1, and then add them up. So I get negative 4a plus a is negative 3a, and then b and negative 2b is negative b, and then of course 4 and negative 1 is 3, and the c's canceled. So that's one of your equations. It's going to be negative 3a minus b equals 3. Okay? Now that's one of the equations. Now let's go to the next slide to finish up what the other one's going to be. So step 1 continued. Okay, so we reduce the systems of the 2 variables into 2 variables. Okay, so we go with the a plus b plus c equals 4 again, but this time we're going to use that one with the third equation, 9a plus 3b plus c equals 4. So typically that's what a lot of people do. They'll use the first and second one and the first and the third one to determine which variable to eliminate. And you're like, why did they eliminate the c? Because it was the easiest one to get rid of. So the c's were easy to get rid of because they all had the same coefficient. So that's why they chose to do that one, particular one. So the top equation is a plus b plus c equals 4, and then we multiply the bottom equation times negative 1 again. We get negative 9a minus 3b minus c equals negative 4. So that turns out to be negative 8a minus 2b, and it equals 0. Now we got those 2 equations. Now solve the resulting system of equations in 2 variables. So negative 3a minus b equals 3 was from the previous slide. And then the negative 8a minus 2b equals 0 is from this slide above. So there's your 2 equations with 2 variables. Now we have to solve for a. and b. This is the same thing from 7.1 that when we were doing 7.1 now. So what they are going to do now is take the top equation and multiply it by -2. And if you multiply by -2, you get 6a plus 2b equals -6. And the bottom equation, we don't do anything with it. We just write it down, -6a minus 2b equals 0. I personally would have probably done something a little different there, but that's okay. So it turns out that you're going to get -2a equals -6. So a turns out to be 3. And once you get that first variable, a or b, or whichever comes out that you found first, then you know the light is at the end of the tunnel. You're close to being finished. Because now all you got to do is back substitute those numbers back into the other equations to find the remaining variables. So the bulk of the work has already been done now. So now that we have a equals 3, so we're going to step 3 is we're going to use back substitute to one of the equations of the two variables that we just did, and they're deciding using the -3a minus b equals 3. You could have used the other one if you wanted to. So remember got a equals 3, so it'd be -3 times 3 because a is 3, minus b equals 3. So you do the math on that one, and b turns out to be -12. Okay, now we got two of the variables. Now back substitute those values back into one of the original variables, into one of the original equations, to find the value of the third variable. And they chose a plus b plus c equals 4. You remember that's one of the original equations that we started with. And we now know a to be 3, we know b is -12, and now we know c is 13. Okay? So we know we know the a now, we know the b now, and we know the c now. And remember, the original the equation that we started with and we were trying to find was the quadratic function. And it was y equals ax squared plus bx plus c, right? That was the quadratic function. Well, now we know the a, and now we know the b, and now we know the c. So we found that a is 3, b is -12, and c is 13. So the equation of the quadratic function whose graph passes through those points is going to be y equals 3x squared, because a was 3, minus 12x, because b was -12, and plus 13, because c was 13. So now that's how you would find a quadratic equation if you're just given 3 points. Okay? So that's kind of nice now that you know that, because now you know if you have a parabola and you know 3 points, any 3 points on the parabola, if that parabola does exist, okay, that's the thing is you may not have a parabola that goes to 3 certain points, but if there is one, you can find it. You can actually find the equation by the systems of 3 equations. So now just how you remember how to do that, go back and look at the slides in order, okay? This would be a very good problem, guys, to look through and know how to do for a test, okay? It's a good application problem, all righty? So you're given 3 ordered pairs. You put that into the function y equals ax squared plus bx plus c, and then you have an equation that has a, b, and c in it, but you got it again and again. So you have that systems of 3 equations. So I would strongly recommend to get this equation and just write it down on a piece of paper from start to finish and see what I'm doing. And not only that, it will give you added experience, examples to look at when you're solving the other types of systems of 3 equations, 3 variables. But all in all, this is not that much more difficult than 7.1. It does take a little bit more time. If you're not a very patient person, that's the people who struggle with this stuff. If you're one of those people who want the answer immediately, you're going to be very frustrated with this, because this stuff here, you got to be patient with it, okay? It takes a while. As a matter of fact, just look at the number of slides it took to do one example, 3 slides. And I try to condense this down into as few slides as possible, okay? So that way it won't seem so long, all righty? So, and even then, it still took me 3 slides to do, all righty? So that's it. I mean, that's pretty much it for what we have to do here. Okay, we're going to be finding other ways to solve systems of equations later, and so be prepared for that. And if you have any questions, let me know as always. Until then, you have a good evening